So we're going to go through the answers to the questions you have in your past paper question section at the back of your Bible. Again, you do have the mark scheme in the Google Classroom, but again, if you want a bit more clarification about the mark scheme or how you should post the questions, skip forward to whatever question you get stuck on and you'll find it here. So question 1 starts with the definition of solubility. Again, as I said in the video before, it's normally given quite a lot of marks for this definition because it's quite a lot of specific detail. So for the first part, you've got a 4-part definition you're looking for. So first mark is the mass, second mark of solute needed to saturate, third mark 100 grams of water, and the bit that people sometimes forget has to be at a given temperature. Part B. A student carried out a series of experiments to determine the solubility of potassium chloride over a range of temperatures. The results were plotted on the graph and shown on the curve overleaf or down below here. What temperature should the student repeat? Again, looking at the graph, there's clearly one anomalous result. You're looking for the one at 40 degrees C, because that does not look like it's on the curve. If a saturated solution of potassium chloride containing 50 grams of water is cooled from 70 to 20, what mass of solid crystallizes out of the solution? Again, a very common style of question in the exam. So you need your solubility values. So solubility at 70 degrees C, just off the graph, should be 134 grams per 100 grams of water. And when you cool it down to 20 degrees C, the solubility drops to 32 grams per 100 grams of water. Now there's kind of a couple of ways around it. You could convert these values so they're out of 50 grams of water, or you can kind of convert afterwards. So if I just subtract them for now, 134 minus 32 is a difference of 102 grams in 100 grams of water. So that's how much should crystallize out. If I had 100 grams of solution, obviously I've only got 50 grams of solution, therefore it's going to be half the amount crystallizing out. So I'm just kind of running over them here for working out. Going to divide by 2, and that would give me 51 grams to crystallize out if it was 50 grams of water. So the final answer is 51 grams. Part C. A factory situated beside a river takes water from the river and uses it as a coolant. The warm water is returned to the river and causes thermal pollution. What effect does the thermal pollution have on dissolved oxygen gas content of the river and on the aquatic life in the river? So maybe it looks like quite a detailed biology style question. All it wants to check you understand is the effect of temperature on dissolved oxygen. And the key bit from your notes is that as you increase temperature, the just say less oxygen can dissolve in water. That's for the effect on the aquatic life, and it's nothing too complicated or biological, just that the aquatic life dies when it's got not enough oxygen. Question 2. A student uses the following method to determine the solubility of potassium nitrate. So again, we'll not worry about reading that word for word for now. So what's meant by the term solubility? It's exactly the same as the one you got before. The mass of solute which will saturate 100 grams of water at a given temperature for 4 marks there. Just out of your notes. For part 2, we're asked to explain a bit of the method. Suggest why the mixture is filtered. Okay, so we've got a slightly different method here than what we've got in our notes. It's not always going to be word for word what you have in your notes. Their method said place 25 grams of deionized water in a beaker, add solid potassium nitrate while stirring until no more dissolves, filter the mixture, place the filtrate on the evaporating basin and heat using a Bunsen burner until it's been removed, calculate the mass of solid obtained. They've done a slightly more intensive technique where they've added solid until no more dissolves. Obviously they've gone past the point of the solubility value because there's extra, but they've filtered the extra solid off and they've evaporated all the water to work out exactly how much solid was added. So it's a good accurate way of working it out. It just would take quite a while. So in terms of why you would filter it, it's just to remove the extra solid that's not dissolved. That's all we're looking for. To remove undissolved solid. Part 3, draw a label diagram of the assembled apparatus used to heat the filtrate. It's just basically the evaporation process, so I'll do that quickly for you now. So that roughly should be what you've got. Again, make sure it's a label diagram. If it's asked for in the question, it's going to be given marks, so if you don't label it, you'll lose a mark. Remember, you don't need to draw a Bunsen burner, you can just do an arrow pointing upwards with the word heat drawn before it. Part B. So from the experiment you get these values for solubility at different temperatures, a couple of calculations to interpret those results. 72 grams of potassium nitrate were added to 100 grams of water at 40 degrees C. After stirring, the solution was saturated and some potassium nitrate remained undissolved. Calculate the mass of potassium nitrate which did not dissolve. So I haven't looked at the calculation like this. So let's look at the temperature first. We've got 40 degrees water and 100 grams of water. So there's no conversions. It's all just in the same units as what's in the table. So at 40 degrees C, our solubility value is 62.5 grams in 100 grams of water. So that's how much 100 grams of water can hold at that temperature. So what we've actually got is 72 grams in that solution, and we're asked to work out how much didn't dissolve. So if I tried to dissolve 72 grams, only 62.5 grams is going to dissolve. So to work out what doesn't dissolve, I just need to subtract from each other. So 72 minus 62.5 gives me 9.5 grams, which will not dissolve in that solution. Part 2, calculate the mass of potassium nitrate which would crystallise if a saturated solution containing 500 grams of water is cooled from 60 to 40. So, need to look for my two solubility values. So 60 degrees C, my solubility is 108 grams per 100 grams. And at 40 degrees C, as we saw before, it's 62.5 grams per 100 grams. So we need to convert it so I have 500 grams of water. I can do that now or after take the difference, but I'm just going to do it now. So if I make it out of 500 grams of water, I need to times everything by 5. So if I do my calculator, 108 times by 5, I get 540 grams, should dissolve in 500 grams of water. If I times 62.5 by 5, I get that 312.5 grams of solid should dissolve in 500 grams of water. So it's a cooling down, so that's the difference in how much can be dissolved at those temperatures. So the difference will give me the amount that's going to crystallise out. 540 take away 312.5 gets me 227.5 grams, and that is the amount that crystallises out to get the marks. So question 3 gives me some more solubility values. Explain what's meant by the term solubility. Again, you see it's a very, very common start to the question. Mass, which will saturate 100 grams of water at a particular temperature, just straight out of your notes. Part 2, use the data on the table to plot the solubility curve, so asking you to actually make it yourself. So again, just plot the graph as normal. So it should roughly look like this. Again, it's clearly a curve, not a straight line, so you draw a curve of best fit rather than a line of best fit. Part C, use that graph to answer the following questions. What's the maximum mass of copper 2 sulfate, which will dissolve in 10 grams of water at 70 degrees C? So you can use my graph to work out what the solubility is at 70 degrees C. So I need to read up my graph, read across, and I should get roughly that the solubility is 47 grams per 100 grams of water. It's only for 10 grams of water though, so you just need to work out to convert it down. 100 down to 10 is just dividing by 10, so that should mean that 4.7 grams dissolves in 10 grams of water. So that's your final answer. Part 2, calculate the mass of tartar sulfate will crystallise out of solution containing 200 grams of water cooled from 75 to 45. So a similar question to what we looked at in question 2. So I need two solubility values at the start, 75 and 45. Using my graph, just reading up and reading across, 75 solubility is 52 grams per 100 grams of water. And 45, it should be 31 grams per 100 grams of water. Again, at this point, I'll choose to just convert those. So I'm going to make them out of 200 grams of water. So 52 times 2 is 104. And 31 times 2 is 62 grams per 200 grams. If I subtract the difference there, 104 minus 62 should give me 42 grams dissolving out by that cooling down. Final question, question 4, starts with a definition of solubility. Again, the mass which will saturate 100 grams of water at a particular temperature. Part 2, we've got a strange question asking you to write the formula for ammonium dichromate. It's basically getting to use the back of your periodic table to do a swap and drop for an unfamiliar compound. Ammonium's ion formula is NH4+. The dichromate ion is Cr2O72-. If you swap and drop them, you end up with NH4 twice, Cr2O7. Then you get given a graph showing the solubility curves for two substances, ammonium dichromate and ammonium chloride. At which temperature, in the first question, does ammonium chloride have a solubility of 55 grams per 100 gram? So you use your graph. So we're looking for a solubility of 55, which is here. You're looking across the ammonium chloride. Read across, read down. You should have got about 59 degrees C plus or minus 1. That's what they give you in a mark scheme. At what temperature they both have the same solubility? You're just looking for where they cross over. That's pretty much at exactly 22 degrees C. Why does the x-axis not go below 0 degrees or above 100 degrees C? Simply enough that water freezes at 0 and water boils at 100. So you'd have a tough time getting anything to dissolve at that point. And part C, a concentrated solution of ammonium dichromate at 60 degrees C, which is not saturated, it contains 30 grams dissolved in 50 grams of water. It's cooled from 60 to 20, calculate the mass that crystallizes out. So that's one of the slightly trickier ones that can catch you out sometimes. If we look at our solubility values, so 60 degrees C, our solubility value is, for ammonium dichromate, I make it about 84. And down at 20 degrees C, I make it 36. So clearly it's not saturated at 60 degrees C because only contains 30. However, once I cool down that, it's 30 grams and 50 grams of water. So to convert it, So I'm going to divide by 2 to make it out 50. So that makes me 42 grams per 50 grams of water. In this case, it's going to be 18 and 50 grams of water. So clearly 30 grams is not going to be saturated at 60 because it can hold 42. However, once it gets down to 20, it can't hold that full 30, it's going to crystallise out. The key thing is I don't subtract 18 from 42 because my solution doesn't contain 42 grams of the solid, it only contains 30. So what I do subtract is 30 minus 18, which gives me an answer of 12 grams. It's going to crystallise out at the end.